My name is Peter Eridix. I'm Esri's Director of Natural Resources Management and Earth Sciences. I'm very pleased to welcome all of you here to the Modernize Your Forestry Workforce webinar series. The objective of this series is to transfer knowledge and best practices so you can learn how to drive measurable improvements in your forestry operations. This is the first of 6 webinars entitled Enhance Operational Efficiencies in Forestry. Today's webinar will provide you with an overview of subjects that we will explore in more detail throughout this series. The material we are covering in this webinar series came from questions raised by the Esri Forestry Group about how to generate maximum return on their GIS investment. They asked to explore out-of-the-box workflows that can be rapidly implemented in any small or large organization. Esri Forestry Group members also wanted to see how Esri's business partners are solving forestry challenges with their innovative solutions. As we discussed the content, we created an exciting agenda that will help you increase efficiencies and help drive your bottom line. Now, I would like to introduce you to today's speakers. I'm pleased to introduce one of Esri's leading forestry partners, Dr. Kevin Lim, who is joining us from Lim Geomatics in Ottawa, Canada. Carrie McKay is a strategic informatics forester and a registered professional forester from Weyerhaeuser. Carrie is joining us from Drayton Valley, Alberta. Grant McCartney is joining us from Timmins, Ontario. Grant is Tembec's Forest Information Systems Coordinator. Jeff Morris is also here from Nakawik, New Brunswick. Jeff is the AV Group's Process Improvement Lead, and he is also a registered professional forester. My colleague, Shahi Raj, is here from Esri Canada in Toronto. Shahi coordinates Esri Canada's business partner relationships. And finally, my good friend and colleague, Mark Books, president of the Esri Forestry Group, is joining us from Fredericksburg, Virginia. Mark is a remote sensing forester from CSU CIML at Fort A.T. Hill. With introductions complete, let's get you orientated with today's webinar. For today's agenda, I will start off with a quick overview of Esri's GIS forestry vision. Carrie will then discuss how Weyerhaeuser is gaining benefit from a web-based forest inventory management system. Grant will share how Tembec is tracking and analyzing harvesting machines. Jeff will talk about how AV Group is monitoring and analyzing their truck fleet for performance and productivity. Shahi will talk about Esri's ArcGIS Marketplace. Mark will introduce the Esri Forestry Group and share free resources available to Esri Forestry Group members. And finally, Kevin will be demonstrating each of the systems for Weyerhaeuser, Tembec, and AV Group. Let's start with this, something many of you already know well. What is a geographic information system, or a GIS? It's basically a system for managing and applying geographic information or knowledge. The system is quite practical in the sense that we can abstract information and update it with workflows and view it through many different lenses. We can create different maps and analytical products. We can also use it to collect measurements or observations in the field and then analyze the data in a multitude of applications. GIS and mapping are now more important than ever. They're essential tools in forestry, providing us a kind of content instead of measures, but also a context for bringing these measurements together for understanding what's going on. It's a science platform, not only for understanding, but also for action. GIS technology is integrating science into virtually everything we do. One element is being able to connect to real-time information, the Internet of Things, such as in-situ data like streamflow measurements or in-field measurements. It integrates remote sensing to measure both the built environment and changes in the natural environment. It integrates models, and you can include big data for deep analytics. Now, some of you have a lot of experience with GIS, but I want you all to realize that GIS is transforming and evolving dramatically. With cloud services, we now have a new pattern of GIS. It's called a web GIS. A web GIS is fundamentally different than the traditional GIS most of you are already familiar with. It's connecting us to a powerful new network of resources to help us address the kinds of forestry business challenges you all face. The individual pieces of GIS that we have all invested in are rapidly becoming part of an interconnected platform. This means integrating a system of record like your timber inventory that is being updated by data collected with apps on mobile devices. We're also sharing content across teams and with consultants through individual identities each with predefined access privileges in what is called a system of engagement. And it also includes a system of insight that allows us to analyze and work with data through apps on desktops and on any mobile device. WebGIS brings three systems together: the system of record, the system of engagement, and the system of insight to help organizations understand increasingly in real time, to be aware, to be alert, and to be responsive. And many forestry organizations are recognizing this is what is needed to break down barriers and connect their teams together. Traditionally, before WebGIS, what we did was take maps and put them into a database, a big bank, and then we could look at it. But this meant that we had to have common data models. We all had to agree. And this centralized approach, while powerful for many years, is now somewhat inflexible. GIS is now about connecting everyone, providing context so that we understand what's going on. GIS and maps are the common language that brings us together. They help us communicate, they help us understand, and they will help us act. Because it's now easy to create new applications with WebGIS, we can finally start to move away from expensive kitchen sink mapping apps, those large, highly customized systems that try to include every function for every user. Instead, with WebGIS, we can now create very focused user experiences. We can tailor the applications to perform only the functions necessary for a specific type of user or workflow. This gives the power of GIS to more individuals in the organization, such as knowledge workers, program managers, decision makers, and executives. As you can see on this slide, we organize applications into three distinct categories: field, office, and community outreach. The field applications cover the full range of tasks that a mobile workforce would need, and includes the ability to track work, navigate to locations, and capture authoritative content at the source. Office applications extend the reach of GIS beyond traditional desktop tools. These enable office workers to consume mapping information into business solutions that they use daily and enhance these workflows through GIS and mapping. The community applications allow users to present their maps to a wider audience, both within and external to their organization. And finally, while mapping is typically associated with GIS professionals, we often overlook the capability to enable mapping for those people within your organization that may not use maps on a daily basis. Thanks to WebGIS, all the employees in your organization now have a vast array of tools available to them to enable the sharing and collaboration of data across your entire organization. As you will see shortly, this enables non-GIS professionals to utilize mapping in their daily workflows. This makes GIS knowledge easy to access and always available. Up next is Dr. Kevin Lim, President and CTO of Lim Geomatics. Lim Geomatics is an Esri business partner who works with Esri's configurable platform and software development tools to provide services and software that extend the ArcGIS platform. Lim Geomatics has created innovative enterprise solutions that leverage the power of the ArcGIS platform for forest management. You will hear business use cases and see demos of solutions that have solved business-critical forestry challenges. With that, I'd like to hand the microphone over to Kevin. Over to you, Kevin.
Thanks for the introduction, Peter. Good afternoon, everyone. Before we launch into the presentations, I wanted to take a brief moment to introduce you to Lim Geomatics. We've been doing business since 2006 and are headquartered in Ottawa, Canada. Over the last 7-8 years, we've been working very closely with Esri and Esri Canada in the capacity as an Esri business partner. It's been a wonderful working relationship. Although today's webinar will focus on our forestry work, we also service the environment, agriculture, pipeline, and defense sectors. Unique to Lim Geomatics is our domain expertise with LiDAR-enhanced forest inventories. To date, we've produced over 15 million hectares or 37 million acres of these types of forest inventories and have demonstrated beyond a doubt the value of these types of inventories to the forestry sector. Today, you'll see some of our products and solutions showcased through our client partners. From a strategic point of view, we all know that an accurate forest inventory leads to good business. And when integrated with an enterprise GIS, business can focus on doing, well, business itself. Lim Geomatics has built its forestry technology on top of the ArcGIS platform and focuses on addressing those hard forestry business questions and needs through business intelligence and analytics. On that note, it's my great pleasure to introduce Carrie McKay, who is the Strategics Informatics Forester at Weyerhaeuser Pembina Timberlands. Take it away, Carrie.
Thanks, Kevin. Thanks, Peter. Thanks for having me as part of this webinar series today. I thought I would start by giving a little bit of an introduction to Weyerhaeuser and Pembina Timberlands. Weyerhaeuser is a forest products company with operations internationally. For more information on the company itself, I've included the website. Operations in Canada are located in 4 provinces: Alberta, British Columbia, Ontario, and Saskatchewan. Pembina Timberlands is located in west central Alberta and is made up of approximately 20 forestry professionals, which not all of them are GIS professionals. The Pembina Timberlands Group manages 1.1 million hectares of crown land for both timber and non-timber values, and all operations on all of our lands are third-party environmentally certified. So managing a data set and a large land base with extremely diverse forest structure presented us with a number of business challenges in this context. Notably, we had aging core data sets that were being adjusted for decision making with subjective factors based on local knowledge, ad hoc data analysis, and everybody's experience. We had obtained FMA-wide LiDAR data, but struggled to serve it to our decision makers in a format that they could utilize. We had new imagery that was being collected and an inventory that was being completed that provided us the opportunity to leverage these new data sets. We had a rich history of stand monitoring and sampling available for compilation. Notably, this data was also georeferenced. So the next step was looking at what was technically challenging us as we look to address these business challenges. So we needed to be able to derive objective estimates of stand condition, preferably using our LiDAR, our inventory, and our plot data, as we felt these were our most advanced data sets. We needed to be able to serve this data to the decision makers of varying technical abilities in a format that they could understand and utilize, ideally using familiar statistics such as gross merchantable volume. We were looking to handle the data less while increasing our capacity to consume it. The interface had to be intuitive, responsive, and dynamic, and it had to be complementary to our current GIS system. Through an exercise of discovery and benchmarking, we began working with LIM Geomatics to address both the technical and the business challenges that I identified. We decided to move ahead with both the creation of our advanced inventory, utilizing our data sets described, and the implementation of AFRID, which is the Advanced Forest Resource Inventory Decision Support System. This is a web-based forest inventory management system that provides our foresters with the tools that they needed to manage our forests and plan our harvesting operations. At this point, I'd like to invite Kevin to take over control and describe the technology that underpins AFRID.
Thanks, Carrie. Okay, at this point in time, I'm going to ask some of the audience to bear with me as I deep dive for a few seconds and introduce the parts of the ArcGIS platform at play for AFRIDS. For Weyerhaeuser Pembina AFRIDS, ArcGIS server has been deployed to Amazon's cloud. GIS map and feature services hosted by ArcGIS server have also been registered in Weyerhaeuser's ArcGIS online organizational account. There's even a third-party system of record that is being leveraged, and I'll show you an example of that in the demo. So at the end of the day, Weyerhaeuser users from any office, whether it be Pembina or Grand Prairie or wherever, can leverage AFRIDS for decision support. All they need is an internet connection. The beauty with the ArcGIS platform is that they can get at the same data using ArcGIS Online, or even those familiar desktop tools such as ArcGIS Desktop and ArcGIS Pro. Even Power BI is at play here. Let me give you a live demo of AFRIDS. I'm going to target 2 use cases. The first demo will show how you can leverage a LiDAR enhanced forest inventory for harvest block calculations. The second demo will show you how you can leverage data from an external organization and use them within your everyday business. This is Weyerhaeuser Pembina AFRIDS. What you're seeing on the screen is a 1 meter hillshade derived from LiDAR for a 1.1 million hectare area. With AFRIDS, we can quickly zoom in and visualize any of the data within the enterprise. So in this case, we're zooming in to take a closer look at that hillshade. Within AFRIDS, you'll notice that it's a very clean design. There's an emphasis on usability, and we test with our foresters, clients to make sure that their needs are met through the user interface. As with pretty much every web app, we have the option to toggle between Esri's base maps. But here, of interest in the ancillary layers is the opportunity to bring in corporate data and make it available to users. So whether it's roads, water, even some imagery, we can go ahead and light the map up with that information. These are made available as web services. So not only can AFRIDS use it, but any other type of enterprise GIS software app, whether it be web-based mobile, could leverage these data sets. So as mentioned earlier, we've been working with enhanced forest inventories for quite a while. So if we wanted to look at the basic derivative product, this is a canopy height model derived from LiDAR data. So every 1 by 1 meter pixel, there's an actual canopy height measurement. We can move this map a little bit, float it around, and get a sense of the spatial variability in height across the land base. But more importantly, with our workflows, we can actually predict quadratic mean diameter on a 20 by 20 meter cell basis. So if we're interested in diameter of trees, we have the opportunity to look across any size land base to actually visualize what that distribution is. I'm going to switch to gross merchantable volume. And again, what we're doing is visualizing volume across a land base. I'm just going to zoom back out to the full extent and then fly back into one particular area just located near the bottom end of the forest. I'll plop in this area. And what I'm going to do now is zoom in a little bit tighter. And I'm going to go to my block control tool. From this view, what I can do is actually click on a tool and say I want to actually draw a block. So I'm going to go ahead and lasso this area. And what we're basically doing is asking AFRIDS what's there. So you'll notice that right away, the results has already come back in the panel here. And it reports that it's 50 hectares. If I scroll down the control a little bit more, it's gone ahead and crunched the enhanced forest inventory derived from LiDAR to report on mean height, top height, dominant height, BA, quad mean DBH, total volume, gross virtual volume. Leveraging existing inventory information, we can break that into species proportions, whether it's pine, aspen, spruce. And we can also look at the distribution of gross merchantable volume across 2 centimeter size classes, in addition to looking at the number of stems by 2 centimeter size classes as well. So the other aspect that I mentioned in the use case that we were going to show was connecting to a third-party system. So I'm actually going to load up these plan blocks. And what you're seeing now on the screen as it refreshes is a block data that's actually coming from a third-party system or record. So we are consuming their actual GIS services from AFRIDS. So as Esri talks about and Esri Canada talks about the systems of systems, that's really come to fruition today. We can easily connect these different systems and work forward. So with this tool, I can go ahead and say I just want to identify one of these polygons, and just with any web-based web mapping application, we can essentially do an identify on that particular block. The beauty here is I can just click on the top menu option and then select the calculate block as an option. And just like that, I'm going to cycle back to my block control. And what we see here is the actual analytics already calculated and completed for that particular block that came from an external system. So at this point in time, I'm going to pass it back to Carrie.
Thanks, Kevin. So post-implementation, we very quickly began to see some of the benefits. Most notably, we were able to get objective data in the hands of those that are making decisions. We had a suite of advanced predictive LiDAR statistics that were easily accessible by our staff of varying technical abilities. In the past, not all of our forestry professionals were comfortable making decisions based on LiDAR data because it was not readily available for them in a format that they easily understood. The solution provides us seamless data transfer in and out of our existing solutions, as Kevin demonstrated. We have a capacity to build upon and customize the solution to suit our business needs as we identify them moving ahead. And probably most importantly was it allowed us the opportunity to leverage existing multi-stakeholder investments to drive that measurable improvement within the company. So we're continuing to work on identifying the next steps for this application and where we see it assisting us even more moving forward. So at this point, thank you very much. And Kevin, back to you.
Thanks for sharing your story, Carrie. At this point in time, I'd like to introduce Grant McCartney, who's the Forest Information Systems Coordinator at Tembec. I'll pass it to you, Grant.
Thanks, Kevin. So a little bit about Tembec. Tembec is a manufacturer of forest products, including lumber, paper pulp, paper, and specialty cellulose. Tembec has operations in North America and France with some 3,000 employees. Tembec directly manages nearly 9 million hectares, or 22 million acres, of Canadian forest land. We have earned Forest Stewardship Council certification on all of our directly managed forests. The business challenges. We're dealing with an aging workforce and a lack of layout contractors. Many of the layout contractors face high turnover and difficulty retaining employees. It's difficult to attract workers willing to run line in challenging conditions. We were looking to reduce the need for physical block layout in low-risk areas. Many of our harvest areas have very little topography, and winter harvesting greatly reduces risk. We were searching for a solution that would help us depend less on physical layout. We also wanted to ensure safe harvesting operations by having the right data in hand for our operators. And we'd like to be able to monitor and quantify productivity of our harvesting equipment. Beyond that, we'd like to be able to report block status, such as the percent complete or the as-built area. Until the implementation of OpTracker, operators relied on handheld recreational grade GPS units that provided only small 2 to 3 inch displays with limited symbology options and no support for imagery or LiDAR-based data. Technical challenges that we faced were how to support Android and iOS tablet devices, so being platform independent, how to get company GIS data onto tablet devices, both our operational business layers and base data, how to seamlessly exchange data collected in the field with the office and between multiple field devices. Many of our operations are shift work that operate 24 hours a day through the winter season. And how are we going to ensure that the necessary security was in place to protect company data? I'll now hand it over to Kevin for an explanation of what ArcGIS pieces are in play with OpTracker.
Thanks, Grant. So OpTracker is a mobile application that's been developed with the ArcGIS Runtime SDK for .NET. So what this basically means is that we've developed it using C# and it allows us to deploy it natively on Android, iOS, and Windows. In fact, OpTracker is available today in the ArcGIS marketplace. For those use cases where 50 to 60 centimeter positioning is required, OpTracker can be paired with an external GNSS device. This is installed within a feller buncher or harvester, and when there's the presence of an internet connection, track data is sent to ArcGIS Online. At that point, once it's in ArcGIS Online, we're back to the usual pattern thanks to the platform that we can leverage ArcGIS Desktop, ArcGIS Pro, even ArcGIS Online again to leverage and mine that data. As you can imagine, accessing these data through customized web apps is beneficial. So we've developed the OpTracker web app, dashboard app, using the ArcGIS API for JavaScript. For those who are interested in visualizing what the OpTracker looks like in a cab, you can see in the image at top right that the tablet, a consumer-grade tablet, is mounted in a consumer-grade mount, in this case a RAM mount, and the only requirement is that there's power to connect it. The same applies to an external GNSS device. Power is provided, the antenna is often mounted on top, covered by Lexan Dome, and the two devices speak with each other via Bluetooth. I'm going to give you a quick demo of OpTracker, both the mobile and the web app. So as I joke, it'll be a day in the life as a contractor for a brief moment here, or an operator, I should say. So on the screen is the OpTracker mobile app. What you'll notice is that the first view is a list of the blocks that are available to the contractor. When we need to add information, we can simply click the Add Block button in the top right. And what happens here is that we're actually querying ArcGIS Online to ask the system what blocks are available. In some instances, I'm going to rotate my iPad just to refresh the screen to ensure that it actually displays on your end. So in this case, you can see that there are several blocks that are available and ready. Blocks can be in preparation mode, on device, or ready for disconnect. So the idea here is that we want to take data offline. So with OpTracker, it doesn't matter if you have an internet connection or not. I'm going to go back to my main view here and pick a block just so you can see what the OpTracker interface looks like for a contractor. I'm going to go ahead and pick 119 and hit the bottom right button, Load Block. And just like that, what's happening is we're starting to query the local data and prepare it for display with an OpTracker so that an operator can go ahead and view it. You likely just heard a beep, and that's because there's alarms that fire based on where you are relative to the actual block. So if the OpTracker operator is getting close to a boundary or entering an area of concern, that might be a riparian zone or a sensitive area, then these alarms will be able to alert the operator to be wary. In the top left, I'll draw your attention to the auto track. So OpTracker has the ability to start auto tracking once the operator with his or her equipment enters the actual block. On the menu side, if I open it up, we can display some tracking information. So if you're paired with an external GNSS device, you have the opportunity to actually look at the accuracy and other types of parameters that are available. If I switch to the layers button, there's also the option to change symbology. There's also the option to side load TPKs or tile packages that may represent your LiDAR hill shade, your predicted inventory data, et cetera, so that the operator can have this data in the field, in their hands, to determine whether they can operate safely on this terrain, whether they should go through this wall of hardwoods because there's more volume behind. And of course, I always joke there's always the measure tool because every forester always wants a measure tool while they're in the field to figure out how they are, where they are relatively. Another thing I'll do is just quickly exit here. So with this, we can go ahead and zoom in. I'll just zoom in briefly here onto the tablet just to show you some of the track information that's collected. So really, it's a seamless, simple user interface that anyone can learn within just a few matter of hours. The other aspect is I'm just going to exit this block. So at the end of the shift, all an operator really needs to do is pick their block that they're working, and in the top right, hit the synchronize button. Just going to wait for the screen to refresh. There we go. And in the top right, once you hit sync, you're done. One thing I'll share with you is that if I go to the settings page, you'll notice that there's a bunch of information that's displayed with respect to your organizational account information. If I scroll down, you can also control the actual tracking settings, so at what interval you'd like to track. You can also control whether you want to auto track or manually track. And the last thing I'll show on the settings side is that you can actually go ahead and set your halo size. So if your equipment has a boom reach of 14 meters, 20 meters, you can go ahead and set that. So that's a quick view of the OpTracker. The next thing I'd like to show you is the web app. So I'll pan over to the OpTracker web app. So in terms of the use case here, I want to show you is how can an organization monitor progress of their equipment and perform analyses such as adds built or depletion calculations. So this is the OpTracker view. At any point in time, I can sort by last update and simply go ahead and start clicking on the various blocks. So in this case, I've clicked on block 381, and the map will refresh and display the actual track information. I can go to block 383 and query that same information. So the idea is that today it's okay to have multiple applications that are fit for use and fit for purpose. There's no need to have multiple buttons, several hundreds of functions. What I'm going to show here is that with this analysis, I can go ahead and simply choose a tracking analysis on this particular block. And then what you'll see on the screen is that we have two operators that have been working this block. And one of them has been working about 143 hours and the other 59 hours. In the top, you'll see a button here in the control. I'm just going to go ahead and click. And what we're doing right now is calculating the percent complete for the block, or in some jurisdictions, this is translated into the as-built area. So it's a nice, simple way of collecting data easily in the field, synchronizing, no need for data files to be exchanged on USBs and whatnot. It's a simple way of making sure data in the field comes back into the office. So on my screen, we've gone ahead and calculated that analytics, and it's 71% complete. And as you can see in the map, that the area in green represents the as-built area. Where we're going with this is that it's all about productive machine hours and productivity. So with the OpTracker, we can easily quantify schedule time. We can quantify idle and non-active time, and we can even move towards breaking the active time component into cutting time. But more importantly, if you have a LiDAR enhanced force inventory, you have the opportunity to calculate actual cubes per hour for every one of these single tracks. At this point, I'll pass it back to Grant.
Thanks, Kevin. Some of the business benefits that have been realized by implementing OpTracker. Our operators now utilize the LiDAR predictive forest inventory metrics and elevation data to better plan their harvest activities. It simplified the data management. Instead of chasing operators to download GPX tracks from various recreational GPS units, the OpTracker data are easily synced to ArcGIS Online and are available through either ArcGIS Online or the OpTracker dashboard app. This tracking information is now used to provide a first cut of depletion mapping, as we just saw in the demo prior to us flying photography. It's shifted the focus of our technicians away from digitizing of depletion boundaries to more of a QC role of just checking the outputs from the OpTracker depletion calculations. This has also improved the operator experience and productivity in that they're able to leverage the LiDAR information products from the cab. And the web app provides staff with up-to-date cut progress information for planning and silviculture activities and analytics for insight into business operations.
Thanks, Grant. Thanks for sharing Tembec's story and its use of OpTracker. At this point in time, I'd like to pass the presentation over to Jeff Morris, who's the Process Improvement Lead at AV Group MB in Nakwith, New Brunswick. Over to you, Jeff.
Thanks, Kevin. And hello, everyone. I want to start briefly with an introduction to who we are as a company. AV Group MB Inc. The Crown licensee in New Brunswick, Canada. We manage approximately 680,000 hectares of Crown land, as well as 40,000 hectares of industrial freehold land. We harvest approximately 1.3 million cubic meters per year. We have 2 dissolving pulp mills in New Brunswick, and we produce viscous fiber to make clothing. So here are some of the challenges we were faced with. Beginning, our trucking parameters were based on assumptions and averages. We treated all origins, destinations the same. So for example, if one truck was trucking wood 80 kilometers from a mill, and the majority of the time the truck was traveling on a paved highway, the trucking parameters were treated the same as another truck 80 kilometers from the mill traveling on slow woods roads. We treated all trucking configurations the same, whether you're a triaxle, quad axle, or B-train. It was difficult to determine actual cycle times, as well as loading and unloading times at the mills. A lot of this was calculated based on recorded times on load slips by the loader operators in the woods and looking at the time that the truck scaled in to the yard. It was difficult to understand the difference between seasonal fuel consumption. Conversations generally revolved around a gut feel approach. There was a lot of emotion involved, and it was very difficult to pinpoint exactly if there was an issue with the cycle time. And just to give you an idea of the complexity, we're managing 115 trucks independently owned by contractors delivering to up to 25 destinations, which are a combination of mills and or yards. So there was a lot of leading change involved in working with our contractors to allow the data to be collected from each truck. As I mentioned, with the independently owned trucks by the contractors, we do not own trucks ourselves. And in order to get these units into the contractor trucks, there was a lot of conversations working with our partners. The biggest issue that came up was the GPS component of the operational tracker for transportation. Mainly had to do with the eye in the sky. And with working with our partner contractors, we had good conversations on the fact that we wanted the data, not the location. So things like road speeds, fuel consumption, unloading times at the mill. The analysis of the data. But we wanted to ensure that as we were doing analysis ourselves, that the contractors had access to the same data so that they could manage their small businesses a lot better. Now I'd like to pass it back to Kevin for a technical explanation of the product.
Thanks, Jeff. So with OpTracker, there's Lim Geomatics Brain Trust that's gone into a Android app, runs on a rooted Android phone. And essentially, it's an app that's been hardened to ensure that no matter what truck condition, whether it's been powered off for 2 weeks or whatnot, the app has an ability to bounce back and start up. So the only requirement is power to the Android smartphone, and there's no tying into the electronics. The other component is a commercial off-the-shelf dongle that goes into the J1939 port. This is standard. Mechanics use this port to diagnose trucks. And the idea is it's providing a bridge to get information from the truck's computer. So when there's a cellular connection, the truck, the phone will pull the truck every so often, and then based on a set frequency with the President's internet through a cell connection, it will broadcast that information to, in this case, AV Group MB's ArcGIS server and Amazon Web Services. So there's a set of feature services and whatnot published there. So just like the OpTracker, for the OpTracker for transport, again, thanks to the platform, we can interact with that data, mine it using Desktop Pro, online, or even our own web app that's being developed using, and once more, the ArcGIS API for JavaScript. So the idea here is we're trying to collect the data and then mine it for business intelligence through various data analytics. So I'm going to give you a demo right now of the OpTracker web app. So the use case I want to address is how a user who may be a manager or a contractor go ahead and view the data and actually calculate a cycle summary. So as I give this demo, you may notice, depending on the refresh of the screen, is that in the bottom right, occasionally you may see a little pop-up that says vehicle updated. So this is a live picture of AV Group MB's fleet, or part of its fleet. It's about 53 trucks that are alive and well and operating. So the first thing I'll draw your attention to is when I click the top right, the people's little button, what will pop up is an actual user control. So a lot of our work, we focus on configuration. So you have the opportunity to essentially assign trucks to different contractors. So when they log in, they only have the ability to view what is in fact theirs. You'll notice the layout is very familiar. It should be familiar by now. It looks very much like OpTracker from the harvesting side of things as well as Afrid. So it's Lim Geomatics mapping framework that's built on top of the JavaScript API for ArcGIS. Same look and feel. We can switch between base maps. We can go ahead and turn on and off the different mills and op plans. So again, this is the platform kicking in. it's not multiple copies of Mills and multiple copies of Oplan. It's one that is being re-leveraged across an average, across an op tracker, across an op tracker for Transport Web App, or even Collector, or even whatever it is, as long as it's platform compatible. So the scenario I'm going to run, let me describe the picture briefly for you. So anything in green represents a truck that's active. Anything in black represents an idle truck, and then anything in red means we're not receiving any engine information from that truck. That may be because the dongle is not plugged in or whatnot. But on the op tracker for Transport Web App, there's diagnostic tools in terms of the battery icon, when it was the last charged, when it was the last synced. So what I'm going to do right now is look for a truck that I know, AV3005, and select that particular truck. And then I'm just going to zoom in and let the webinar catch up. And so what we're actually showing is AV3005. It's traveling right now at 18.7 kilometers an hour. So this is a live picture. And you can see based on the breadcrumbs which direction it's traveling. It's heading north right now. For this given truck, I can click on the truck panel on the left. And what it'll do is pop up a control that says zoom to vehicle, calculate cycle, create vehicle summary, or export points to shapefile. So for this use case demonstration, I'm going to calculate a cycle. I'm going to go back in time and pick a period back in December where I know there's data, December 5th. And then I'm going to go ahead and pick December 6th as the other date. And then the control will just allow me to simply say calculate. And what we're doing right now is querying all those millions of data points and applying our algorithms to build up these individual segments within this cycle summary. To start off with, there's an unknown stop for about 2 hours. Perhaps this was the driver's home. And then there is an unknown stop to block 203. 010E, doesn't matter, it went to a block. And what you'll see on the left on your control is whether it's a stop or whether it's travel. So this was a 1.5 hour travel, distance 80 kilometers, 53. On the actual segment, we can look at the speeds. So for those organizations interested in driver behavior, you have the opportunity to look at that. And then as well, for those interested in fuel economy and whatnot, we also have the opportunity to grab that. At the end of the day, we can pull whatever data points off of the ECM on the truck. So the key thing that Jeff mentioned was that at some point in time, we're interested in load time. So in block 203, based on the control here, 38 minutes load time. Then it traveled from the block to an unknown stop, and eventually it ended up at Shaw Resources, where it spent 23 minutes unloading, doing work there. So you have an opportunity here to analyze, mine, apply the power of the ArcGIS platform to essentially gain insights into this side of the business. So at this point, I'm going to pass it back to Jeff. Over to you.
Okay, thanks, Kevin. So what you're all seeing here is a contractor report. So all the data that Kevin just showed us how to obtain is neatly packaged on a report that's sent out by automatic email to our supervisors, superintendents, managers, as well as the contractor for their trucks. One thing to note, so what we have here is, I guess, is production machine hours by day, the mill unload times, complete with a rolling 4-week average, so that we can identify trends, whether that's the unloading times are improving or not, as well as the productive hours, 4-week rolling average, to measure trends. There's some trip summaries there as well, and then the trip details, start, end time, productive times. So this allows us to really pinpoint areas for improvement by comparing with our top performers. So the business benefits, as you mentioned, all of our trucking fleet is independently owned by contractors, and so it's to assist with the health of their business. As our partners, the expectation is that they are improving their businesses at the same rate as ours. Good lead indicators of progress. We're able to determine root causes in order to create actions to drive improvement. We're able to pinpoint cycle time opportunities and gaps. And the gut feel approach that we had in the past has now turned into a discussion that is more of a fact-based. A lot less time back and forth discussing emotional events and really getting down to the facts and the figures to talk about improvement. So what we realized through this process is that we were able to use speed points for more than just the trucking parameters. So what you're seeing here on your screen is a before and after shot. Before shot, this is a 6-kilometer road that's basically showing different levels of speeds along the road. And you're able to identify areas where the speeds of the trucks are dropping down. So we're using this data to dispatch our road graders as well as our road maintenance contractors to these locations, specifically to increase speeds for the truck. So on the after shot, you can see there's a lot more yellow and green, a lot less orange and red. This provides immediate feedback to the contractors on the progress and performance of their road maintenance activities. And certainly the road maintenance dollars that we are spending today are spent wisely compared to in the past. In the past, we would have probably dispatched the road grader to grade the entire 6 kilometers of road. Now we are able to pinpoint certain areas that need to be improved, which saves us time and money in the long run. So extending capabilities, what you're seeing here is an app that was developed for our environmental management system. In the past, before the app was created, we lived in a world where everybody was going around, contractors, supervisors, superintendents, managers, with sheets upon sheets of paper, forms, checklists that need to be filled out, inspection sheets. And we've conveniently, with the help of LIM Geomatics, been able to create this app that allows us to have all of our inspection sheets and checklists all in one location. There's the capability of taking photos and also setting reminders for the individual. And so everybody in the woods has this on their phones. And the beauty about it is once you get into a Wi-Fi location, you're able to sync the data. The data goes to the ArcGIS platform. There's a lot less manual work as far as somebody gathering up all the loose sheets of paper and putting them into a database manually.
Now, I'd like to introduce Shahi Raj with Esri Canada. Among other things, Shahi works with LIM Geomatics and other Esri partners to help the Esri partner community get their apps approved for the ArcGIS Marketplace. Over to you, Shahi.
Thank you, Peter, and good afternoon, everyone. The ArcGIS Marketplace is a destination that allows ArcGIS Online organizations to search, discover, and get apps and data from qualified providers. And these providers are from our Esri business partner community, Esri itself, Esri distributors, and the Esri startups. So how does one go about searching on ArcGIS Online Marketplace? At the bare minimum, an ArcGIS Online subscription is what is required. You can then search, and depending on the provider, you can request free trial or make a purchase. For those of you who are not familiar with ArcGIS Online, during the next webinar series, we'll be taking a closer look at ArcGIS Online. As Peter mentioned, LIM's OpTracker application is now available on the ArcGIS Marketplace, which means that they meet the qualification and they are integrated with ArcGIS Online platform. I would encourage you to have a look at OpTracker, and as you can see, you can request a 30-day free trial available. So at this point of time, I'll hand it back to Peter.
Thanks, Shahi. I've asked Mark Book to say a few words about the Esri Forestry Group. Mark has been supporting the strong and growing forestry community since 2008. He and his fellow co-founder, Elizabeth Martinez, have been instrumental in driving the development of free resources that you might find useful, including the creation of this webinar series. Over to you, Mark.
Thank you, Peter. What is the Esri Forestry Group, or EFG as I often refer to it as? Well, it's a community of forestry professionals using ArcGIS with the purpose of being a venue for collaboration. The size of the group and the diversity of its members make it possible for all participants in the forest industry to have a forum for requesting tools and solutions. This collective voice makes it possible to garner the attention of Esri for industry-specific tools, applications, and resources. The goal is to be that one, or at least first, stop shop for all things forestry GIS, thus making EFG an advocate for a worldwide community of those practicing forestry and GIS. EFG is a user group that formed in 2008 and has grown to over 3,300 members worldwide. members fall into three categories: Esri end users or customers, such as myself, also solution providers, and Esri staff. And it takes all three categories working together to meet EFG's goals. That is to create that one-stop shop for all things forestry and GIS, keep forestry in the forefront at Esri, make resources available, and much more, but all done with the intent of increasing members' return on their GIS investment. So we have some upcoming events. Well, this webinar series will continue, so look for those dates. And if you're able to attend the Esri UC, be sure to look for the special interest group meeting, Forestry SIG, which will be July 12th on Wednesday then. So just wanted to point out our resource center is available through ArcGIS Online at that web link shown. So that's the landing page shown on the right, and as you can see, there are many story maps. But I also encourage you to check out the tabs group to find many more resources, such as the Esri Forestry GIS conference proceedings with videos. There's also training materials and other forestry and GIS related resources. You're welcome to connect with us via social media. For instance, so the list is there: Twitter, Facebook, LinkedIn, and GeoNet. The LinkedIn group has over 5,000 members. Feel free to join us at the link shown there. It's very important to continue adding members, basically because the more we have, the bigger voice we have. And EFG needs the numbers to maintain the attention forestry receives from Esri management and developers. But also, it needs to be a two-way form of communication. The Esri Forestry Group needs to hear from its members about their GIS requests for solutions. Thus, collectively pooling our technical know-how and building solutions, well, it makes for better forest management, data collection, and analysis opportunities. So thank you for your time. Peter, back to you.
Great, thanks, Mark. I'd like to share some concluding remarks. We hope that many of you have seen something today that you think will be valuable to your organization. I want to take this opportunity to thank all of our speakers, Carrie, Grant, Jeff, Kevin, Shahi, and Mark. We really appreciate you sharing all of your business use cases and enterprise solutions with us. Please also keep an eye out for the upcoming email announcements announcing the webinar number 2, which is Managing the Field Workforce. This will be held on August the 9th. We will soon launch a landing page where all the registrations, the recordings, and Q&A documents will be made available to you. Once again, today's webinar is just the first of 6 webinars. Today's webinar was intended to give you an overview of subjects that we will explore in more detail throughout the rest of the series. Each webinar will feature different guest speakers, including speakers from state and federal agencies and a variety of Esri partners with exciting forestry solutions to share. Before you go, let me conclude with a couple of comments. We have shared a lot of content, and I know this has been a very dense webinar, but I believe that we need to start thinking about modernizing the forest industry. Right now, many of us are just trying to cope with the challenges we face on a daily basis. But many are not building plans to create a better future for ourselves, our employers, and our communities that rely on healthy forests and a healthy forest industry. I know that many of you are developing one thing or the other, and some of you are even implementing some technology solutions. But it's my sense that we now have to begin to make a plan for the future that leverages everything that we know. And in your world, creating a better future means, I think, geo-enabling forestry professionals of all types, from those taking measurements in the field to the decision makers in each of your respective organizations. I think that this will make a huge difference. For those of you interested in learning more about LIM Geomatics and their powerful solutions built on the ArcGIS platform, please visit their website at www.limgeomatics.com. There's also contact information on their website, so you can connect directly with Kevin or any one of his staff who will be happy to discuss their solutions and help you with your forestry challenges. And for those of you interested in learning about Esri's forestry program, please visit our website at go.esri.com/forestry. You can view a story map about new solutions for forestry, and you can also watch a video to learn about the U.S. Department of Agriculture Forest Service's use of ArcGIS to collect and share authoritative data for more than 800 million acres of forests. And finally, download and read a white paper for forest and land managers to learn how forest companies are transforming long-term business value, income, and performance by innovating beyond business as usual. There is also a convenient form for you to get started today and contact the Esri Forestry team. And for those of you on Twitter, please follow us on the channel @EsriForestry. To our speakers today, we are grateful for the time and effort you took to share your business challenges, solutions, and experiences with the global forestry community by participating in this webinar. Based on the incredible number of participants joining us today from 61 countries around the world, I believe the forestry community can benefit immediately from the methods and workflows you have shared with us today. Thank you for your contribution. And of course, thank you to LIM Geomatics for all that you do. And please accept our sincere appreciation for sharing your time and expertise with us today. For participants, thank you for taking the time out of your busy schedule to join this webinar. We all hope you found the information presented will be useful in your day-to-day work. We look forward to receiving your calls and emails, and we'll be looking for you online on our next webinar in several months' time. Goodbye for now.